2 weeks of darkness, temperatures dropping to -250 degrees, a place where solar power fails, and where survival seems impossible. Yet NASA has set its sights on conquering this frozen night with something humanity has never built in space before: a nuclear reactor on the moon. Here's the problem. A single day on the moon lasts about 29 Earth days. That means 14 days of light, followed by 14 days of total darkness. Solar panels work great during the day, but for 2 weeks of night, they're useless. And in craters at the poles where sunlight never reaches, solar is not an option at all. If we want permanent human bases, life support, and research stations, we need a power source that doesn't depend on sunlight. That's why NASA is turning to nuclear fission. It's called the Fission Surface Power project. The idea: build compact reactors that can provide at least 40 kilowatts of continuous electricity, enough to power habitats, mining systems, rovers, and life support. And NASA's ultimate goal: a reactor capable of producing over 100 kilowatts by the year 2030. These reactors would be small, modular, and light enough to launch on a rocket. Once on the moon, they could be deployed remotely, set up to power bases without relying on human crews to assemble them. This isn't science fiction. NASA already tested a ground prototype called Killer Power, which ran successfully for 28 hours in 2018. Next up, we are scaling that tech for the moon's surface. How does it work? Unlike giant nuclear plants on Earth, these reactors are simple, compact, and designed for safety. The moon reactor would likely use uranium fuel and a closed Brayton cycle system to convert heat into electricity. The whole thing has to weigh less than 15 metric tons, small enough for a single launch. Radiation shielding is another challenge. Astronauts must be protected, so reactors would be placed far from habitats, possibly shielded with lunar soil. These designs focus on reliability: no moving parts where possible, and systems that can run for years without maintenance. But this isn't just about science, it's about power. Literal and political. China and Russia are already planning their own lunar reactors, aiming for the 2030s. If they get there first, it's not just about bragging rights. Nuclear power means permanent bases. Permanent bases mean influence, resources, and control. The moon isn't just a dead rock. It has water ice that is essential for drinking water, breathable oxygen, and even rocket fuel. Whoever masters lunar energy will control access to those resources, and in space, control means dominance. That's why some call this the second space race. The first was about who could land a human on the moon. This time, it's about who can stay there. Imagine a base at the moon's south pole, powered by a reactor humming beneath the surface. Lights glowing through the endless night, astronauts mining ice, building habitats, testing technologies that could one day sustain colonies on Mars. This isn't just about surviving, it's about thriving. A moon base powered by nuclear energy could open the door to industry in space, mining rare metals, building fuel depots, even serving as a launch point for missions deeper into the solar system. But the question remains, who will get there first? NASA wants the first reactor running by 2030. China and Russia are aiming for the mid-2030s. The race is real, and the stakes are higher than ever. Nuclear power on the moon will decide more than the future of exploration. It could decide who leads humanity into the next age of space. The new space race has begun. Don't forget to like, subscribe, and hit that bell to see more videos about the world around us. Thanks for watching.